Okay, here we go. Today, the first part is definitely challenging. The second part is very easy. Okay, and so you'll see. If you could get through this first part, the second part is no big deal at all. Okay. What's that? Okay, whatever you say. Our goal today is to take some trigonometric expressions and try to reduce the powers or lower the powers. You might wonder, why would we want to do that? Well, if you have sine squared of x, in calculus, that could be a very complicated expression. For example, if I were to try to determine the integral of sine squared of x dx, um, I, I just really couldn't do that, okay? But if you tell me that sine squared is the same as 1 minus cosine of 2x divided by 2, well, then I can do that integral. That would be no big deal for me. Do you wonder how we get from here to here? Okay. All right, we'll accept it. Cosine, if you have cosine squared of x, that's equal to 1 plus cosine of 2x over 2. And if you have tangent squared of x, this should hopefully make sense to you. You could take sine divided by cosine. If I were to take these two expressions and divide them, the 2's would cancel. Very good. I get 1 minus cosine of 2x over 1 plus cosine of 2x. So, you notice that, first of all the powers are reduced. Instead of a second power or third power or anything like that, you have the first power, and all the expressions have cosine. So the directions for this type of problem, when you get to your assignment or your test, would read something like this. Rewrite the following expressions in terms of the first power of cosine. I have sine squared times cosine squared. So I have two powers that exist that I want to get rid of. And I don't want sine, I just want cosine. So I'm going to rewrite sine squared as 1 minus cosine of 2x over 2 times 1 plus cosine of 2x over 2. What's that, Gracie? They are conjugates, and conjugates are great because the middles will go away. You'll see as we will work it out. We have 1, and there'll be plus cosine of 2x, and we'll have a minus cosine of 2x. And when we take negative cosine of 2x and positive cosine of 2x, we get a negative cosine squared of 2x. Nothing happens with the angle. The 2x stays the same. All divided by 4. So Grace pointed out that because they were conjugates, what's going to happen? These cancel. I'm left with 1 minus cosine squared of 2x all over 4. So have I gotten rid of the signs? Have I gotten rid of the powers? No. Shoot. Oh. Now the nice thing is that I know what cosine squared of x is, but I don't know yet what cosine squared of 2x is. I mean, look it up here. I've got this formula for cosine squared of x. The question is, what would be a formula for cosine squared of 2x? Oh, boy. As we went from here to here, what happened to the angle? It doubled, right? So the angle will just double. So we get 1 plus cosine of 4x over 2. So now I can express this as 1 minus 1 plus cosine of 4x over 2 all over 4. Complex fraction. How will we simplify? So I have 2 minus 1. And will that be a positive cosine of 4x or a negative cosine of 4x? Negative cosine of 4x over 2 over 4 over 1, right? How do I simplify? Multiply by the reciprocal. 1 minus cosine of 4x all over the wonderful 8. Right here. Right here. Oh, so right, sine squared of 2x would be 1 minus cosine of 4x divided by 2. You won't ever have to use that. You'll be all right. Okay, so excellent. I just want to be clear how you can write your answer. Obviously, this answer is acceptable, but so is 1 over 8 minus cosine of 4x over 8. Or if you're a person who likes to factor out a 1/8, then write as 1 minus cosine of 4x. That would be okay too. You have some options. How's that? Question? So I just multiply by the reciprocal. Better? For this guy? Yeah. So we know that this is equal to that. And so what we want to focus on is the angle. As we move from this formula to this formula, we can see that the x moves to a 2x. Or in other words, the angle doubles. So if I double 2x, what do I get? 4x. So that's why I have 4x there. So that way we can create any angle that we want. So, for example, if we had cosine squared of 5x, I know that that's equal to 1 plus cosine of 10x over 2. We simply double the angle. Is that better? Excellent. You sure can. That was way too easy. Let's try something slightly more challenging. Sine of x to the 4th. Oh boy, oh boy, oh boy, oh boy. What do I do? Take the log of both sides. Okay. 4th root both sides. 4th root both sides, and you have sine of x, and you are done. Good job. Sorry, I'm sorry. We started to make that joke yesterday. It's just a good time. It is hysterical. Thank you. But you have an idea. Okay. Cross out the whole problem. Done! All right! Yeah! Check the box. Okay, all right. There you go. All right, so if you see this problem, we would go negative infinity, positive infinity. All right, there we go. That is the domain of the problem. So that's good for you for noticing that. Does anybody know the range? Negative 1 to 1 is not quite right, because if you take something to the fourth power, you only get positives, right? So therefore the range would be 0 to 1. So sorry. Now would it be open bracket or closed? It'd be closed for the range, open for the domain. All right, let's do serious stuff. Sine squared of x times sine squared of x. Yep, I just separated the stuff that I know. So we're going to go 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. Are these conjugates? No, so the middle doesn't go away. So we multiply them out. 1 times 1 is 1. Then negative cosine of 2x times 1 and negative cosine of 2x times 1. Negative 2 cosine of 2x, right? Plus cosine squared of 2x all over 4. Great, so I have cosine to the first power now, but I don't have cosine to the first power for the very last one. So I'm going to have to get rid of that cosine squared of 2x. Good thing we know what that is. Thank you. That's a line I like to use. I mean, really for the most part, the trigonometry is done. Now it's just a matter of some basic algebra, right? Let's simplify the complex fraction. We have 2 over 2 minus 4 cosine of 2x over 2 plus 1 plus cosine of 4x over 2 all over what? 4. That's correct. The angle does not change. All right. Are there any terms that are like each other that you can combine in the numerator? The 2 and the 1. Thank you. So we got 3. So get rid of the 2 and the 1. I have a negative 4 cosine of 2x. I have a positive cosine of 4x. That is all over what? 2 over 4 over 1. Multiply by reciprocal, and I get 3 minus 4 cosine of 2x plus cosine of 4x, big 8. And there is the answer in all of its beauty. Yes, William. I don't know that answer. I don't know how to do that. But I do know how to do this. Integral 1/8 times 3 minus 4 cosine of 2x plus cosine of 4x dx. I do know how to do that problem. So the operative word here is pre-calculus. So for those of you who will move on to take calculus, without a doubt, they hope that in your trigonometry class, you learn how to do these power reducing pieces. And although when you take the calculus course, you will not say, oh yeah, I know exactly how to do that. You should be able to say, yes, I've done that before. It's not magic. I think I can accomplish that. And with some notes, hopefully you can work your way through it. But this is definitely a calculus piece that you will use. Not used very much in trigonometry. And like William said, 90% of the time, you're going to want to leave the expression like that, sine to the fourth. You're not going to want to leave it as what you see here at the end. But in calculus, this is a lot easier to work with, without a doubt. We like that. So. Oh, yeah, thank you. Yes, yes. All right. All right, let's do something easy. Yeah. We're done with the challenging stuff. I think the rest of the stuff we learned is pretty simple. From this point to the test, I think everything's pretty simple. I think it'll be all right. Let's do it easy. Okay? We have a great way of using some of the formulas that we've used so far in trigonometry to be able to write products as sums. That means you can take multiplication and write it as addition, which is also a very useful thing, especially in calculus. So we want to take this product and write it as a sum. So we're not going to write down all these formulas because they get redundant and they're sitting right there in your formula sheet. What's really cool is we've learned these formulas. These ones we chose to skip. This was last unit, last unit, last unit, last unit. Sum and difference, 7.2. Even odd identities, we did this beginning of 7.1. Cofunction, we proved those in 7.2. Double angle, we did those yesterday. Half angle, did those yesterday. Power reducing, that was today. This is old stuff right here. And right now we end with sum to product and product to sum. So there's your entire formula sheet laid out for you. You can see that you've covered everything now. So let's look at our sum to product, product to sum. I think it says sine times cosine for our first example, doesn't it? It's sitting right there. So it looks like it's 1/2 sine a plus and then a minus. So I'm going to try to remember that. You guys tell me if I write it down correctly because you have the star quality of paying attention. 1/2 times sine of a plus b plus sine of a minus b. We're good there? Did I write that down correctly? The rest of the product to sum formulas you can find on your formula sheet. You can also take a sum and write it as a product. So I have sine plus sine. If I glance at my formula sheet, I can see the sum to product formulas right here. I'm going to ask somebody to please communicate to me what I should be writing down. 2 times sine of a plus b divided by 2 times there we go. So the key is to make sure you can locate the formulas properly and they'll make good use of them. It says write the following product as a sum. This is a product. We want it to be addition instead. I'm going to use my very first formula that I wrote down. The formula says 1/2 times the quantity sine of a plus b plus sine of a minus b. So what I need to do is I need to identify in this problem what is a and what is b. A is 4x, b is 2x. So I have 1/2 times the sine of what is a plus b, 6x, plus what is a minus b, so sine of 2x. And you are done. That's it. You're welcome. I want to be clear, some people will do this. They will take 1/2 times sine of 6x, they'll get sine of 3x. So that's kind of what Rowan was referring to earlier. Let's continue to do the voodoo math. That does not work out. Is everybody convinced that these expressions are not the same? Whoop. So if I have 1/2 times 6 squared, I could just do, let's see, that's 3 squared, which is 9, right? Due to order of operations, you must square first, right? Just like in order of operations, you have to take sine first before you do anything else. Right. That's really for arithmetic. Yeah. All right, we move on. Here I have 3 times the entire piece. Can somebody tell me how to take cosine times cosine and convert it to a sum? I'm guessing it's a 1/2 times what? Plus or minus? But there's a plus between these two? Okay. All right, so what's A in this problem? X. What's B? So I get 3/2 times the cosine of, what is A minus B? Negative X plus cosine of 3x. Hey, something's wrong here. I can't leave a negative angle. Why? Yep. Due to your even and odd identities, we know that cosine, you can just simply take the negative angle and make it a positive because, yep, because it's an even function. And there you go. Okay, so I can see people are kind of thumbing through their sheet here. Remember, your even odd identities, they're right here. You can see that cosine and secant, the negative on the angle just goes away, whereas all other 4, the negative moves out front. Because all the other functions are odd functions, which means the negative moves to the front. The other functions are even, which means the negative simply goes away. Yes. Yep. Well, I'm sorry. So in this situation, can I address it when it comes up here? Okay. Yes. Can I show you? If I type in -2 and +2 to x squared, what do you get? You get 4 either way, right? So what you're telling me is that negative 2 squared is the same thing as 2 squared, right? That's because this is what we call an even function. Cosine of x is also an even function. So therefore, cosine of a -2 is the same thing as cosine of a +2. Just like -2 squared, the same as 2 squared. Because they are even. Okay. If you want further explanation, we're going to have to kind of digress later on. So. All right, here we go. Let's switch it. Let's take the following sums and write them as products. Do you see a sign minus sign somewhere? Can you tell me what I get? Did I write that correctly? Okay, what is A in this problem? 3x. B is x. So I have 2 times the cosine of, what is A plus B divided by 2? 2x times the sine of, yep, 3x minus x is 2x, divided by 2 is just x. Very good. So we took the sum and we wrote it as a product. That's it. So we took 3x plus x was 4x, and we divided it by 2. I just pulled the formula that you told me, right? Is that the formula? So I take A plus B. So A is 3x. Yes. Yep. Okay. All right. The next one, again, yes. here's where you'd be in trouble. Suppose you were writing like the sine of x plus 4. That, if you're taking the sine of both of those, you have to write it. Okay. But people would assume that if you're doing multiplication, sine of 2x, you don't really have to write the parentheses. If you weren't taking the sine of x, then you would have to write as x times the sine of 2. That's how we would want to see it. Yes, it's always safe to just do that, but generally we understand in math what that means. So, okay, all right. Tell me the cosine subtraction. What do I get? -2 sine a plus b divided by 2 sine a minus b divided by 2. You can see that they are similar, aren't they? As you look at these formulas, it's hard to remember which is which. So you just kind of, you check your sheet. So in this problem, what is A? And what is B? So I get -2 times the sine of 11x over 2 times the sine of. Okay, so the question was, what if it came out to be a negative there? Well, in this situation, because it's all multiplication, you can just take the negative and put it out to the front and then make it positive, okay? But if it wasn't all multiplication, then you would just move it to right in front of that sign. So if it was like, say, sine plus, then it would become or plus sign, then it would become a negative there, okay? So it depends on how you're writing the expression. So you can see here it's all multiplication, so you can move the negative all the way up front. But in a situation like this, the negative would just come there and change it to subtraction. Okay, let's finish off. This one problem is written incorrectly. I forget to change it every year. It's 75 degrees, not 45. But it says find the value of the product or sum. Does anybody know what the exact value is of sine of 105 degrees? I don't either. And so therefore, I'm going to use a formula. I'm going to take my chances and try to convert this to a sum. Because I notice if I add these two together, I get 120. And if I subtract them, I get 90. And those are nice angles I like to work with. So this is equal to 3 times, how do I convert this to a sum? 3 times a half times something, I bet. What is it? Sine of, it's cosine. 1/2 times a cosine of a minus b. There we go. So we've got a formula here. And so I've got 3/2 times the cosine of, what will a minus b result? 90. Minus the cosine of, what is a plus b? 120. Who here knows what the cosine of 90 degrees is? It is 0. Very good. The terminal point is 0, 1, and cosine is the x value. So you therefore have, hey, stop, stupid board. Okay, smartboard is angry. How about the cosine of 120? We locate that terminal point. Very good. -1/2. So you get 3/2 times 1/2, which is 3/4. Turns out that's the exact value. If you take on your calculator and type that out, you probably do come out with exactly 3/4. You're going to need to show your work on the test if that comes up. So, all right, last example. Now we have subtraction. Yeah. And the last example we have a difference, and we're going to try to write it as a product to see if we can maybe kind of work these pieces out. My guess is we have a -2, is that correct? Times a plus b over 2 sine of a minus b over 2. Great. So I've got -2 times the sine of, what is a plus b, then divided by 2. 45. times the sine of what is a minus b divided by 2. 30. Okay, so I got negative 2 times sine of 45 times sine of 30. What is the sine of 45? Very good. Root of 2 over 2. And what is the sine of 30? 1/2. It's the y value on the 30-degree angle, which is 1/2. Negative 2 times 1/2 is negative 1. So we get negative root of 2 over 2. Bada bing, bada bam, bada boom. In isolation, these problems don't look that bad. When you start to do them all mixed together, all of a sudden you start to get confused, which is why on Thursday, we are going to take some time to review chapters 7.1 through 7.3. Your assignment for today, I cut it down from previous assignments. Thank you, Mr. Gens. You're welcome, everybody. Okay, so here's what you can do. 7.3, page 557, do numbers 9 and 10. If you'd like to, do 11 and 12 for fun. You go right ahead and do that. If you'd like to have some extra fun, I told you how to do sine to the 4th, but maybe you want to try doing something like, say, sine to the 8th times cosine to the 8th. I don't see any takers out there. Yeah, that's very challenging right here. I couldn't put this as extra credit on the test because it would take the entire hour to do it. So, and then you have 37 through 40 and 43 through 50. That is 6 problems reduced from what I gave last year. So, because I care about you so much. Goodbye, YouTube Nation. Shout out to Jackson. We hope to see you soon. Anybody else gone? Kenzie, bring back something from Florida, like what? Seashells. Starfish.